Have you ever pondered the mysteries of our early universe and the enigmatic primordial black holes? Imagine a time billions of years ago, just moments after the Big Bang, when the universe was a hot, dense, and rapidly expanding soup of particles. In this chaotic infancy of time and space, the first seeds of cosmic structures were sown. Among these seeds, theorists propose, were primordial black holes. Unlike their stellar counterparts that form from the collapse of massive stars, these primordial black holes are thought to have formed from extreme density fluctuations in the early universe. The very existence of these primordial black holes is a topic of ongoing debate. They're elusive, leaving only subtle hints of their presence, and yet their potential implications are profound. They could play a crucial role in cosmic evolution, contribute to the elusive dark matter, and even offer a window into quantum gravity. These primordial black holes, if they exist, could hold the key to unraveling the mysteries of the universe. Now imagine a black hole not as an eternal cosmic vacuum, but as an entity that can shrink and eventually disappear. This is where the concept of Hawking radiation comes into play. Named after the brilliant physicist Stephen Hawking, this theoretical prediction has stirred the world of astrophysics like a cosmic whirlwind. Hawking proposed that black holes are not the ultimate devourers as we once thought. Instead, they can emit particles, which we now call Hawking radiation. This happens due to the funky quantum effects near the black hole's event horizon. In the simplest terms, it's like the black hole is slowly evaporating, losing its mass over time. Here's a fun way to picture it. Imagine the region around a black hole is a dance floor. Particle-antiparticle pairs are constantly popping in and out of existence, dancing around each other. Now, if one of these pairs forms near the event horizon, one particle might fall into the black hole while the other escapes into space. The escapee becomes part of the Hawking radiation. So, what's the catch? Well, the energy for the escape particle has to come from somewhere, right? It's actually borrowed from the black hole itself, reducing its mass ever so slightly. This is what we mean when we say a black hole evaporates. Now, if you're thinking, well, that's cool, but what's the big deal? Here it is. If Hawking radiation is real, it could mean black holes have a lifespan. They aren't eternal. Given enough time, a black hole could radiate away all its mass, shrinking down to nothing. A complete game changer, isn't it? But before we get too excited, remember, Hawking radiation is still a theoretical prediction. It's incredibly difficult to detect due to its minuscule energy. But don't lose hope. Efforts are underway to observe this elusive radiation, potentially validating Hawking's groundbreaking theory. So even the seemingly immortal black holes might have an expiration date. Stay tuned for more cosmic insights as we continue to unravel the mysteries of our universe. But how do we detect these elusive primordial black holes, you ask? Well, it's a bit like looking for a needle in a cosmic haystack. But there's a fascinating method that scientists use, one that involves the bending of light. This method is known as gravitational lensing. Imagine a light beam traveling through space. Now, if a massive object, say a black hole, comes in its path, the light doesn't continue in a straight line. Instead, it bends around the object. This is because the massive object creates a dent in the fabric of spacetime, causing the light to follow a curved path. This phenomenon is what we call gravitational lensing, but we're talking about primordial black holes, which are tiny compared to their cosmic counterparts. So we need something a bit more sensitive, a refined version of gravitational lensing, known as microlensing. Microlensing events occur when a small mass object, such as a primordial black hole, passes right in front of a star. The starlight bends around the black hole, creating a temporary increase in the star's brightness. This sudden brightening of the star is our clue that a primordial black hole might be lurking nearby. Detecting these microlensing events is a painstaking process. It requires monitoring millions of stars for years on end, waiting for that tiny blip in brightness. But the good news is, we have the technology to do it. Several ground and space-based telescopes are keeping their vigilant eyes on the sky, recording and analyzing starlight from all corners of the universe. In recent years, researchers have reported potential microlensing events that could be indicative of primordial black holes. These findings are exciting, but they're not definitive proof just yet. There's still much to learn, much to discover. As we continue to probe the depths of the universe, we inch closer to understanding the nature of dark matter and the origins of the universe itself. These microlensing events, although rare, could potentially help us detect the invisible primordial black holes. Let's delve deeper into the early universe, back when the first light elements were born. The process that brought these elements into existence is known as primordial nucleosynthesis. This is the creation of the light elements, namely hydrogen, helium, and traces of lithium, that occurred in the first few minutes after the Big Bang. Imagine, if you will, a universe so hot and dense that it was practically a nuclear fusion reactor. As it expanded and cooled, protons and neutrons began to combine, forming the nuclei of these light elements. The relative abundance of these elements remains a telltale sign of those first moments of creation. But what does this have to do with primordial black holes, you might wonder? Well, these black holes are believed to have formed in the early universe, around the same time as primordial nucleosynthesis. By studying the distribution and abundance of light elements, we can infer the conditions of the universe at that time, including the potential existence of these primordial black holes. It is a fascinating thought, isn't it? That by examining the very elements that make up the world around us, we can glimpse into the origins of the universe itself. And perhaps, just perhaps, these investigations might reveal the existence of primordial black holes, adding another piece to the cosmic puzzle. The very atoms that make up life as we know it could have been forged in the heart of a primordial black hole. Our journey into the mysteries of the early universe and primordial black holes comes to a close. We've delved into the theoretical realm of Hawking radiation, hinting at the evaporation of these cosmic behemoths. We've explored microlensing events, a tool to detect the shadowy presence of primordial black holes. And we've unraveled the role of primordial nucleosynthesis, shedding light on the cosmic origin of light elements. The answers to these cosmic mysteries await us in the stars as we continue our quest to understand the universe and our place within it.